connection to topic 9? Systems of linear equations in 3 variables. Okay, on the first one, we have 3 equations, and each equation will have up to 3 variables, okay? So I have negative 5a plus 6b plus 3c equals 23, and I have negative 6a minus 5b plus 5c equals negative 24, and I have negative 3a minus 2b minus 2c equals negative 1. And to keep it easier so you know what equation that I'm referring to, I like to label these as equation A, equation B, and equation C. So step 1, you are going to choose 2 equations to start with, and you are going to choose which variable that you would like to terminate. You will choose 2 equations to start with, and you will choose a variable to eliminate. Okay, so I'm recording this in a class that we had one example yesterday, which was a C day, and I'm kind of starting all over again because my recording did not work out right. So an example that I gave yesterday, we chose 2 equations to start with that had a variable that would automatically eliminate without me multiplying, right? But in this one, if I pair any of those equations together, will I have any variables that'll eliminate without me doing any multiplication? No. Okay, so that happens. So if that's the case, then I would at least try to pick 2 equations where I would only have to multiply one of them to get something to eliminate. And if that wasn't possible either, then I'm just going to have to pick 2 equations that I'm going to have to multiply both, okay? But if nothing eliminates automatically, at least try to pick something where you would only have to multiply one equation. So anybody have any ideas of what I would choose? Parker. A and C. If I chose A and C, what would you eliminate? The B. And that's what I would pick too, because I would only have to multiply equation C by 3, right? And that would turn that into a negative 6b. It would eliminate with positive 6b. I could choose B and C, and I could multiply the bottom equation by a negative 3, which is fine. But if I do this one, I don't have to deal with the negative. Okay? Can I choose a million other things? Well, maybe not a million. I can choose whatever I want, right? I'm just trying to choose what's easiest. So that's what I would pick as well, A and C. And we are going to eliminate the b's, which means we will have to multiply that bottom equation by positive 3. And the top equation, I don't have to multiply by anything, so I'm just going to rewrite it. And then the bottom equation, I'll distribute the -3 to every single term, even on the other side of the equal sign. So 3 times -3a is -9a. 3 times -2b is -6b. 3 times -2c is -6c equals 3 times -1 is -3. So we wanted the b's to eliminate, and they are going to. So now combine like terms, pay attention to the sign. -5a and -9a make -14a. The b's eliminated, I don't need to write plus 0. 3c minus 6c is -3c equals +23, -3 is +20. So I've created a new equation. I can't solve for a or c. Well, I can, but I won't get a number. Okay, I'll have a variable on the other side. So I'm going to now call this equation D. And I'll come back to equation D in a little bit, okay? So we started with equation A and C. We have not used equation B yet. All 3 equations have to be used to get the ordered triple that will make all 3 equations true, okay? So we're going to have to pair equation B with either A or C, it doesn't matter. But since we eliminated the B in the first step, whichever equation we pair it with, we're going to have to eliminate the B, okay? So step 2. Does anybody have any questions so far? You must choose equation B now because you haven't used it yet. Pair it with either equation A or C. Since we eliminated the B term in step 1, we must eliminate the B term in this step. So I know I'm using equation B, so we'll go ahead and write that down. And make sure you write all the terms correctly. It's easy to, there's so many numbers and signs and this and that and so many different equations, it's easy to just make a mistake writing the wrong thing. So we're going to pair that with either equation A or C, and we have to eliminate the B. So the B term in equation B is -5b. Is one of these going to be easier than the other? Not really. We're going to have to multiply both equations regardless, right? The only thing is I would probably pair it with A just because the B term's already positive and this one's already negative. That's just one less thing you have to worry about. But either way, you're going to have to multiply both equations, so it doesn't matter. So I'm going to choose to go with A. Make sure I wrote it down correctly. -5a plus 6b plus 3c equals 23. -6a minus 5b plus 5c is -24. Okay, so we're eliminating the b's. What's the least common multiple of 5 and 6? Or just a multiple. You can't think of the least, just a multiple. 30. What? Yeah, 5 and 6 would be 30, right? So I would multiply, if I want to turn negative 5b into negative 30b, I would multiply the top equation by 6. And the bottom equation, if I want to turn positive 6b into positive 30b, I would multiply by 5.
So you're allowed to multiply the equations?
Yep. Sometimes you have to. Sometimes you can't. They won't cancel automatically, and you can't cancel them with just multiplying one equation. So that happens. So I'm going to multiply my top equation by 6. And my bottom equation by 5. Now tell me if I make a mistake on my math. Everybody good with that? So as long as I did not make any errors, my b's cancel, which is what I wanted to happen. Combine like terms, so negative 36a minus 25a is negative 61a. Positive 30c and positive 15c make positive 45c. Negative 144 plus 115 is negative 29. So again, I have two variables. I eliminated one of the variables, now I still have two. So we are going to call this equation E. So notice we created equation D above. It had A and C. We have created equation E. It has variables of A and C. If we would have eliminated a different variable here than we did in step 1, when we pair equation D and E together, they would have different variables, and that's not going to help us much. Okay, so that's the whole purpose of, doesn't matter which variable we cancel in step 1, as long as you cancel the same variable in step 2. Does that make sense? Okay, so the whole purpose is we're trying to whittle this down to figure out what one variable is, and once we do that, then it's easy. Well, none of it's difficult, but it goes a lot quicker. So step 3, now pair equation D and E together, but you can see why I label these A, B, C, D, and E because there's so many. Now a pair equation D and E together. And choose a variable to eliminate. What variable does it seem like might be easier? C. Because if we eliminated the C's, we would only have to multiply that top equation by what? 15. If we eliminate the A's, I don't know what the least common multiple is, but if I would multiply the bottom equation by 14 and the top equation by 61, whatever we get would eliminate, right? But those are going to be some big numbers, and I have to multiply both equations. So I would just choose to multiply the top equation by 15. And distribute. So 15 times negative 14 is negative 210. A. 15 times negative 3c is negative 45c. And 15 times 20 is positive 300, and there is an equal sign before the 300. Bottom equation, I'm not multiplying by anything. So I'm just rewriting it. Okay, so now combine like terms. Negative 210a minus 61a is negative 271a. Negative 45c and positive 45c cancel. And 300 minus 29 is positive 271. So now we have one variable a. We can finally solve for that variable. Divide both sides by negative 271. And a equals negative 1. So we know one variable. We have to know all three variables, right? So if I substitute a equals negative 1 back into equation a, b, or c, will I be able to solve for just one of the other variables to get a number? No. I'll have to use either equation d or e, because if I substitute in a is negative 1 into either of those, then that only leaves me one other variable. I can solve for that variable and figure out what it's equal to, right? A number, not another term with another variable in it. So I'm going to do that on the next page. Anybody have questions so far? Nope. Everybody good? So step 4. Now that we know a equals negative 1, substitute a equals negative 1 into either equation d or e. And it does not matter which one, we will get the same exact result regardless of which equation we use. So I'm just going to choose D because the numbers are smaller. It does not matter if you choose D or not. Just make sure you write it down correctly. And I know that a equals negative 1. So negative 14 times negative 1 minus 3c equals 20. Simplify on the left side. Negative 14 times negative 1 is positive 14. Minus 3c equals 20. My only variable now is c. I'm going to solve for that. So I will subtract 14 from both sides. 14 minus 14 cancels. Now, I do not bring down 3c, I bring down negative 3c. A lot of students are still forgetting that the sign to the left of the term goes with the term, okay? And a positive 20 and a negative 14 make a positive 6. Divide each term by negative 3. Negative 3c divided by negative 3 is c, equals positive 6 divided by negative 3 is negative 2. So now I know 2 out of the 3 variables. So now I can go back and substitute into equation A, B, or C. Because now if I use D or E, I know both variables. I won't have any variables to solve for, right? So this is the point, step 5. Now substitute A equals negative 1 and C equals negative 2 into either equation A, B, or C. Yes. Oh, thank you. Yeah, A equals negative 1. Sorry about that. I wrote down positive 1. If you did too, make sure you write negative 1. So I'm probably going to choose A. The numbers are a little bigger, but there's not as many negative signs. And just trying to avoid making mistakes, that's probably what I would go with. So I know A is negative 1, so that's negative 5 times negative 1, plus, I don't know B, that's what I'm going to be solving for, so plus 6B, plus 3C, instead of 3 times C, that'll be 3 times negative 2, equals 23. Let me simplify on the left side. Negative 5 times negative 1 is 5, plus 6B, positive 3 times negative 2 is negative 6. And before I start moving stuff over to the right, I can combine like terms because I have two constants. So 5 minus 6 is negative 1, plus 6B equals 23. Now we'll start moving stuff over to the other side to try to isolate the B. So 6B equals 23 plus 1 is 24. Divide by 6 and B equals 4. So remember, we have 3 variables now. So 3 is not an ordered pair, it's an ordered triple. And we have to write them in alphabetical order just like you do ordered pair. Okay, X comma Y, alphabetical order. When you have 3 variables, alphabetical order. So step 6, write your answer as an ordered triple. In this case, the variables they used were A, B, and C, so we would do A, comma, B, comma, C, comma. The order in which you found the variables does not matter, okay? But when you write your answer, the order does matter. So A was negative 1, B was positive 4, and C was negative 2. So if we were graphing these, it would be on a 3-dimensional graph, and this would be the ordered triple where all 3 of those lines intersected. Okay, we don't have to do the graphing part in algebra 2, we just have to be able to solve them algebraically. Everybody cool with that? So technically in this class that was example 2, but for the purpose of the video I'm going to leave it as example 1. Y'all order yours however you want to. Okay, so now I'm going to go a little bit faster. Does everybody have this written down? I'm not going to write all those steps. I'll just talk them out. And I'm calling this example 2. Our first equation is negative 2a minus 5b minus c equals negative 3. And we have a plus 2b plus c equals 0. And we have negative 3a minus c equals negative 6. And again, just so I have a point of reference, I'm going to label these as equation A, equation B, and equation C. Nothing to do with the variables in the problem, okay? Just as a point of reference. Now, do y'all know anything weird? Notice anything weird about this one? The last one, missing B, right? So we're going to do this one a little bit differently. Actually, we'll be able to solve it much quicker. Any ideas? Maybe. You could have 0B. You could do that. We could also do something else that'll make it a little faster. Yes, ma'am. Okay, I think I heard you. The air conditioner's loud. I think you were saying what I was thinking. If we were to pair equation A and B together and eliminate the B, then we would have A and C, which we could pair up with equation C, right? So it's kind of like we'll be able to skip a step. Since this one's already missing the B term, we'll pair these together, eliminate the B, and I can pair it with equation C. So each problem is going to be different. If they don't all three have three variables, then don't get confused by it. It's actually easier and faster. Okay, you just got to think about what you're going to do to the other two equations. Okay, so we will pair equation A and B together. Did I get that right? Was that what you were saying? Okay, good. And we will choose to eliminate B. Even though the C would eliminate automatically, if we eliminate the C, we're going to be left with A and B, and that's not going to help us pair it with equation C. You know what I'm saying? So if I want to eliminate my B's, are they going to cancel automatically? Can I multiply just one equation by some number? No, I'm going to have to multiply both, right? So what can we turn the B terms into? 10. Negative 10B and positive 10B. Does everybody understand that? So the top equation I would multiply by what? 2. And the bottom equation I would multiply by 5. And I wrote over here, so I'm just going to go down below to write my new equation A and B after distributing. So A would be negative 4A minus 10B minus 2C equals negative 6. Don't forget to distribute across the equal sign. Bottom equation would be 5A plus 10B plus 5C equals 0. And my B's cancel just like I was hoping they would. Combine like terms, negative 4A, positive 5A gives us positive 1A, or just A. Negative 2C plus 5C is positive 3C, equals negative 6 and 0 makes negative 6. I'll call this equation D. And because I strategically eliminated the B's, now I can pair equations C and D together. They both have A's, they both have C's, and I can eliminate one of them. Everybody good with that? Now, since I'm already down to 2 variables, does it matter which one I pick? No, it doesn't have to be the same as above. Well, first of all, it doesn't have a B, okay, but this one's a little bit different. So, and these really look like either, no matter which one I pick, it's going to be same amount of effort. So if I eliminate the top, or if I eliminate my C's, I would multiply the top equation by 3, and if I eliminate my A's, I would multiply the bottom equation by 3. Does not matter. I'll just go with the top equation. So that would give me negative 9A minus 3C equals negative 18. Bottom equation, I will not have to multiply by anything. Did I make a mistake? So my C's cancel. Negative 9A, and that's a positive 1A, makes a negative 8A equals negative 24. Solve for A, and we get negative 24 divided by negative 8 is positive 3. So I know one variable. I could either substitute that into equation C or equation D, and solve for C, right? Does not matter which one. But don't put it in A or B because then you're going to have two unknown variables. So I'll just go with equation D because there's less negative signs. And I know that A is equal to 3, so instead of A, I'll put a 3. Now my only variable is C, so I'll solve for that. So 3C equals negative 9. Divide each term by 3. C equals negative 3. I know 2 out of the 3 variables. Now what will I do? Substitute into what? Either A or B. I can't do C because C only has 2 variables in this case, and I know both of them, so it won't help me, right? So either A or B. I will go with B. So we know A is 3. I do not know B. I know C is negative 3. So plus or minus 3 is the same thing as minus 3. Combine like terms on the left side. 3 minus 3 is 0. So basically I'm left with 2B equals 0. Solve for B. Or, I'm sorry, divided by 2. What is 0 divided by 2? 0. So my answer as an ordered triple, I have to do A, comma, B, comma, C. So that would be 3, comma, 0, comma, negative 3. Y'all getting the hang of it? Okay, let me do one more. And then I'll give you your assignment, which is about 25 problems. Or 3. Just 3. Any questions before I move on? Example 3 for the video, example 4 for the audience. This audience, not the YouTube audience. Okay, I have 3x plus y minus 4z equals negative 7. And the next equation I have 6x minus 5y plus 4z equals negative 7. And then I have 5x minus 3y plus z equals negative 7. And again, I'm going to label these equation A, B, and C. It does not matter which 2 equations we start with, right? When we go over the homework, the only thing that makes these difficult is that we can all start in different places, and that's okay. So that makes it kind of difficult. If I go over it and I start in one place but you start in the other, it's hard for you to find the mistake, but I can't go over it 10 different ways. We just won't have time to do that. So that's why I'll give you the answers to the homework so you can check it as you go. Okay, so let's look at this, and if we're strategic, are there any 2 equations that we could pair up to start with that would have a variable that eliminated automatically without any multiplication? Yes, Millie. If we paired A and B together, what variable would you want to eliminate? Z. That's the easiest choice, right? If we pair these 2 together, Z's will eliminate without any multiplication. So that's definitely where I would start. No, that is not your only option, but that is going to get you to the answer the fastest. And I know that is what you all normally prefer, as do I. So if I pair these 2 equations together, negative 4z and positive 4z eliminate or cancel, or they're 0. Combine like terms, positive 3x and positive 6x make 9x. What is positive y minus 5y? Nice. And is negative 7 minus 7, do they eliminate? Oh, what is it? Negative 14. So if I solve for x or y, I'm still going to have another variable. So I'm just going to call this equation D, and I'll come back to equation D in a minute. So now remember, we have not used equation C yet. All three equations have to get used. So that means either A or B or will get used a second time, and that's okay. But C, all of them have to be used at least once. And what a variable, is it up? Does it matter which variable do we eliminate now? Yeah, it does, right? It's got to be Z, because that's what we eliminated here. So if we pair equation C with A or B, and we have to eliminate the Z, which one do you think I would choose? I would. Can I choose B? Yeah, why would I choose A? Because it already has a negative. This one has a positive. You know, to eliminate, one's got to be positive, one's got to be negative. So not that we couldn't turn that into a negative, but it just saves us a step, right? So yes, I would choose to pair this with equation A. And as you can see, my z's are not going to eliminate automatically, but I will just have to multiply the top equation by what? 4. Distribute. 4 times 5x is 20x. 4 times negative 3y is negative 12y. 4 times positive z is positive 4z. Equals 4 times negative 7 is negative 28. Bottom equation, I'm not having to multiply by anything. My z's eliminate, which is what my goal was. Combine like terms, positive 20x, positive 3x is 23x. Negative 12y and positive y is negative 11y. Equals negative 28, negative 7 is negative 35. I've got two variables here. If I solve for one of them, I'm still going to have a variable on the other side, so I'll just call this equation E. Now what do we do? Yep, pair D and E together. They both have x's and they both have y's. We did that on purpose. So once we get to this step, does it matter if you eliminate the x's or the y's? No, it's totally up to you. Neither of them are going to eliminate automatically. If we choose one variable or over the other, will we just be able to multiply one equation by some number? No, no matter which one we pick, we're going to have to multiply both equations, right? So I would probably go with, what do you think I would go with? Why do you think I would go with y's? You're correct. Yeah, the numbers are smaller that we have to multiply by, right? That's the only reason. You could definitely go with x's. That's up to you. So what does 4 and 11, what could we turn them into? 44. And one's got to be positive, one's got to be negative. Right now they're both negatives. Does not matter which one you turn positive. I'll just go ahead and turn the top one positive. So that would mean I would have to multiply the top equation by what? Negative 11. So if I want to leave the bottom one negative and turn it into a 44 using multiplication, I would multiply by what? 4. So I distribute the negative 11. I get negative 99x plus 44y equals positive 154. Bottom equation, I will distribute the 4, and I get 92x minus 44y equals negative 140. My y's will eliminate as I had planned. Combining like terms, negative 99x to positive 92x make negative 7x. And 154 minus 140 is 14. Solve for x. Am I finished? Stop here. I found what x equals. No. I have to find all 3 variables. So when I get to the point where I only know one variable, would I substitute that into A, B, or C? No. What would I substitute it into? Either D or E, because there's 2 variables. I know one of them. I can solve for the other. Does not matter which one you choose. I'm probably going to go with D since the numbers are smaller. I know x equals negative 2, so that would be 9 times negative 2 minus 4y equals negative 14. That gives me negative 18 minus 4y equals negative 14. So now our only variable is a y. I will solve for that. Add 18 to both sides. And I get negative 4y equals 4. Divide by negative 4, and y equals negative 1. Now I know 2 out of the 3 variables. So now I can either substitute both of those into A, B, or C. It doesn't matter. I'm going to choose A. So I know x is negative 2, so 3 times negative 2. I know y is negative 1, so plus a negative 1 is the same thing as minus 1. Minus 4z equals negative 7. Now my only variable is z. I can solve for that. Be careful with your order of operations on the left side when you're simplifying. Let me take care of this multiplication first. So I get negative 6 minus 1 minus 4z equals negative 7. Let me combine like terms before I move them over. Minus 6 minus 1 is negative 7. Minus 4z equals negative 7. I'll add 7 to both sides. So I get negative 4z equals 0. Divide by negative 4, and 0 divided by negative 4 is 0. So as an ordered triple, x comma y comma z would be negative 2, comma negative 1, comma 0. Again, I'm not writing that in that order because that's the order that I found the variables, but that's alphabetical order. That's the correct way to write it. Do we have questions? Don't feel like we can do this pretty well? Okay. Then I'll end my video.